Good morning, dear students. I welcome all of you in my class. Today I am going to teach you exercise 1.4, which is the last exercise of your first chapter, real numbers. Let's start. In this exercise, I am going to telling about you real numbers, which is a combination of rational numbers plus irrational number. First of all, I am revising some previous concepts once again to you to make this exercise easy for you. Okay, let's start. Every natural number is in whole number, and every whole number is in integer, and every integer is in rational number. I am telling again, every natural number is a whole number, every whole number is in integers, and every integer is in rational numbers. Natural numbers are, you already know, 1, 2, 3. Whole numbers, when 0, 1, 2, 3. Integers, -1, -2, 0, 1, 2 up to infinity. Rational numbers, the numbers which can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. And irrational numbers which cannot be expressed in the form P by Q. And every rational number, by if I taking its decimal part, every rational number is finite or infinite plus repeating decimal. And irrational number is decimal part, infinite and non-repeating. Let's revise again. Every natural number is in whole number, and every whole number is in integers, and every integer is in rational number. But rational numbers and irrational numbers are totally different, but they both make a real number, which is our today's topic. Rational number plus irrational number is equal to real number. Now in this exercise, we are dealing with irrational numbers and their decimal expansion. Rational numbers and their decimal expansion. Rational numbers have either their decimal expansion in the form terminating decimal expansion, for example 0.375. By eliminate decimal form, I am converted into simple rational form. 1000 is equal to 375 divided by 10 raised to power 3. Other form, non-terminating repeating expansion. For example 2.6666, it goes on. It can be written in the form 2.6 bar. Okay, the rational numbers can express, rational numbers have either a terminating decimal expansion or a non-terminating decimal expansion. In this session, we are going to explore exactly when the decimal expansion of rational number is terminating or when it is non-terminating, repeating, recurring. Two cases are there. One is terminating and second is non-terminating repeating expansion. Our exercise is dealing with these two concepts. First of all, I am explaining you theorem 1.5. Let x be a rational number whose decimal expansion is terminates when x can be expressed in the form P by Q co-prime, and prime factorization of Q is of the form 2 raised to power n, 5 raised to power n, where n and m are non-negative integers. For example, 3 by 8. Factors of 8 is 2 into 2 into 2. It is terminating. 2 multiplied by same value 5 raised to power 3. Same value multiplies and divides. After getting, I am getting 375. 3 multiplied by 5 multiplied by 5 and 2 multiplied by 5, 10. You know, if bases are same, if degrees are same, then we multiply bases. 2 multiplied by 5, 10, 10 raised to power 3. If I want to write in a decimal form, the decimal form is like this, 0.375. It is a terminating. Our first case, terminating decimal expansion. Now, come to the theorem 1.6. 1.6 theorem. Let x is equal to p by q be a rational number such that prime factorization of q is of the form 2n 5m, where n and m are non-negative integers, where x has a decimal expansions which terminates. The main important thing is that if the denominator is written in the form 2 into 5, 2 raised to power m and 5 raised to power m, then it is a terminates, otherwise it is not a terminates. Now theorem number 1.7. Let x be any number, p by q be a rational number such that the prime factorization of q is not of the form 2 raised to power n, 5 raised to power m. In theorem number 1.6 and 1.7, we are dealing with when the denominator is in the form of 2 raised to power n and 5 raised to power m. But in theorem number 7, let pq be a rational number such that the prime factorization of q is not of the form 2n 5m, where n and m are non-negative integers. There has a decimal expansion which is non-terminating repeating. When the denominator is not written in the form, not written in the form 2 raised to power n and 5 raised to power m, in that case the decimal expansion of rational number is non-terminating repeating expansion. Theorem number 1.5 and 1.6 is dealing with this case, and theorem number 1.7 is dealing with this case, non-terminating non-expansion. For example, from in your 9th class, you already studied 1 by 7 is 0.142857. It goes on repeating. Then I am putting bar on 142857. Conclusion from the above discussion from the theorem 1.6, 1.5, 1.7, we conclude the decimal expansion of every rational number is either terminating or non-terminating repeating. This is our today's topic. Rational number have either a terminating expansion or a non-terminating expansion. The simple test is this: if the denominator is written if the denominator can be written in the form 2 raised to power n and 5 raised to power m, only in that case it is a terminating, otherwise it is not in terminating, it is a non-terminating repeating expansion if it is a rational number. Okay, now I am going to teach you exercise 1.4. First question: without actually performing the long division, state whether the following rational numbers will have a terminating decimal or a non-terminating repeating decimal expression. Okay, so first of all, this point is commit to memory, and this point is from our theorem 1.6, 1.5 and 1.7. We know that if the denominator of a rational number has no prime factors other than 2 or 5, then it is a terminating, otherwise it has a non-terminating repeating expansion. I am taking first part, 13, 3, 1, 2, 5. 13 divided by 3, 1, 2, 5. Denominator is 3125. On making factors, I am getting 5 into 5 into 5 into 5. All factors comes into the power of 5, 5 raised to power 5. Hence has a terminating expansion. Hence has a terminating expansion. 2 raised to either 2 or 5. Listen again. Prime factors other than 2 or 5, either in the form of 2 or 5 or 2 and 5 both combinations, then it is a terminating, otherwise it is not a terminating. I am taking one more question for you. Fifth part, 29 divided by 343. By making factors of denominators, I am getting 7 into 7 into 7. This is an other number other than 2 or 5. That's why prime factors other than 2 or 5. So it will not have a terminating decimal expansion. I am taking one more question for you. That is the seventh part. 129 divided by 2 raised to power 2 into 5 raised to power 7 into 7 raised to power 5. Denominator has prime factors other than 2 and 5. So it will not have a terminating decimal expansion. I hope you understand this concept very clearly. If the denominator can be expressed in the form 2 or 5 factors or 2 and 5 combination factors, only in that case it is a terminating, otherwise it is not a terminating. Now come to the second question. Write down the decimal expansion of those rational numbers in question number 1 which have terminating expansion. Means when we are solving question number first, those cases which are terminating, only for the second question we have to write its decimal expansion. Otherwise, if it is non-terminating, we only write non-terminating. I am taking first question because in the first question I have a terminating decimal expansion. Now I am writing the decimal expansion in the decimal form. How I am writing this? Here I am getting the factors of 3, 1, 2, 5 is 5 raised to power 5. Now I am multiplying by same power of 2. Multiplying by 2 raised to power 5. The same number is multiplying and dividing numerator and denominator both part. After solving, I am getting 3 into 2 into 2 into 2 into 2 is equal to 416. In denominator part, I am getting 5 multiplied by 2, 10 raised to power 5. 10 raised to power 5 means 1, 0, 0, 0, 0. 5 times zeros. After changing into decimal form, I am getting answer 0.00416. Question number part number 5 and 7 both are non-terminating, so there is no need to solve it, only we have to write non-terminating. Now I am coming to the question number 3. The real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? Okay. Now I am taking first question. 4, 3.1, 2, 3, 4, 5, 6, 7, 8, 9. It is a terminating. It represents a rational number in P by Q, where Q is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 raised to power 9. Next number is 0.0.1201200120001200 and so on. Given number is non-terminating and non-repeating, so it is a irrational number. So it is a irrational number because it is non-terminating and non-repeating. Now come to the third question. This number is in the form of a bar. Given number is non-terminating but repeating, so it is a rational number. Okay, so it is a rational number. Rational numbers and irrational numbers both makes a real number. The number whose decimal expansion is finite and which can be written in the form P by Q are rational numbers. The numbers which cannot be written in the form P by Q, those numbers are called irrational number. But both numbers makes a real number. Both numbers makes a real number. Is it clear? Both numbers makes a real number. Now you are go through this exercise 1.4 and do very neatly in your fair copy. Your first unit is completed. Now you revise thoroughly. If you face any problem, test me with your problem. I am very happy to solve your problem. Always remember one thing, I love you all and always with you. Thanks.